Hello, I am Dr. Manoj Mahajan, Assistant Professor, Department of Physics, VZ Vajay College, Autonomous, Mulund, Mumbai. I would like to present our research work entitled Synthesis and Dialectic Studies of Tryptophan Dope European Fluoride Nanoparticle. Before I will start my presentation, I would like to say thanks to the organizers for providing me the opportunity to present our research work in this eminent conference. So, uh, let us first understand why we have chosen European fluoride as our host material. So, if we will look at the literature review, so lanthanide based material find the wide application in the light emitting devices because of their sharp emission characteristics. In the lanthanide series, European based fluoride, because of its rare emission, find the application in the cathode ray displays. Now, as far as electronic circuits are concerned, dielectric material plays an important role in it, and these dielectric properties are influenced by the size and the morphology. The frequency dependent dielectric behavior provide the valuable insight into the charge transport polarization mechanism of the synthesized nanomaterial. So, uh, as far as the synthesis part is concerned, we have followed the simply chemical route where we have synthesized the nanoparticle at the room temperature. For that, we have taken 7 ml of europium chloride. In that, we have added 1.5 ml of holmium chloride, 1.5 ml of tryptophan, and swiftly we have ejected 10 ml of ammonium fluoride. We have taken the ratio of 1 is to 4 because this ratio gives us the maximum output. So once we have added all these four reagents, we got the formation of this white precipitate. This white precipitate we have kept under microwave oven for 50 to 60 minutes and we got the formation of this white powder which we have used for the characterization purpose. We have done several characterization but here we are reporting only the dielectric studies of the synthesized nanoparticle. So when we have plotted the graph of dielectric constant against the frequency, please note we have varied the frequency from 100 Hz to 5 megahertz. So the plot indicates the dielectric constant is very high at the lower frequency and as we will move on to the higher frequency range, it remains constant, which is a very important thing. Secondly, the dielectric loss. It is very high at the lower frequency and as we move on to the higher frequency range, it remains constant. That means at the higher frequency range, the dielectric loss is not only the low, but it remains constant. The third plot that is tangent of dielectric loss. So it is again high at the lower frequency range, and as we are move on to the higher frequency range, it goes on decreasing. Okay. So, and lastly, when we have plotted the graph of log of epsilon dash against the log of frequency, it approximately shows a straight line with the slope of 0 minus 0.74, which indicates its application in the DC conduction process. So, from this, all these four plots, we have concluded that in the higher frequency range, where we are actually working in the communication field or especially in the microelectronic circuit, we want the material to be stable. So from this all these four plot, we conclude that the material is behaving as a stable material at the higher frequency range. So we find its application in the electronic industry. So in the conclusion, we have synthesized holmium dope europium fluoride nanoparticle in the presence of tryptophan as a surface modifier by the fluoride use. Please note we have synthesized this nanomaterial at the room temperature. The XRD study shows the particle size of the order of 73.54 nanometer belonging to the hexagonal phase. As far as dielectric studies are concerned, The dielectric study shows exponential decrease of dielectric constant as well as dielectric loss, suggesting the space polarization effect. The slope of the graph, that is log of epsilon, which I just said, that is minus 0.74, is of synthesized nanomaterial, shows its application in the basic conduction process. Now, the low value of dielectric loss at the higher frequency, suggesting its application in the electronic industry. So, these are the few references that we have used in this particular thing. So at the last, I would like to say thanks to BK Birla College, where I have carried out all this synthesize part and the characterization part, and of course my college, that is Vijay Vijay College, for their constant support and encouragement. Thank you.